Here's 2014 question 2. This is an area and volume problem. So they don't really tell you what graph is which, but it's kind of intuitive here. Notice how they have a horizontal line. So it's implied that that's pretty much y equals 4, and that this curvy one must be f of x. Okay? So here we go. Find the volume of the solid when you rotate this about y equals -2, which is somewhere down here. So since the equations are in terms of x, we want to favor a vertical rectangle so that we don't have to change the equations, okay? So if you notice, the rectangle in relationship to the axis of rotation is perpendicular, so not parashell. So we want to use either a disc or a washer, but since there's a large gap in between the rectangle and the axis of revolution, we know that it has to be a washer method there, okay? So here we go. I'll start on the upper left. So the volume will equal pi integral of your outside squared minus your inside squared dx, okay? Now, what are the bounds? The bounds is pretty much where they intersect, okay? So what you can easily do is graph y1 as f of x, graph y2 as 4, graph the 2 and then calculate your intersections, okay? So you would just go to second, trace 5, and you know what to do next, okay? You should be able to get 0 and 2.3. Your intersections, again, is where the region starts and stops. So the only thing we have left is the outside and the inside, okay? So here we go. The outside, remember, you always start from your axis of revolution. Where you're about to exit is your outside. Where you're about to enter or go in is your inside. Okay, so here's what we know. I know that from here to here is 4. And I know from here to here is 2. So how do I get this red outside line, right? So it's basically just 2 plus that function 4. Okay, so in this case, it's going to be 2 plus the function 4 squared. Okay, same thing here. I know that from here to here, it's 2. But from here to here, it's just f of x. So how do I get that shorter red dotted line? It'll just be 2 plus the function. So it'll be 2 plus f of x dx. From 0 to 2.3, you got the pi on the outside. Plug in chug, you should get 98.868. Okay? Here's part B. The region R is a base of a solid. We have a cross section that's perpendicular to the x-axis. So remember, perpendicular to the x-axis just implies that you're going to integrate with x, okay? So right away, I know I'm going to integrate with x. So here, the cross sections are going to be an isosceles triangle. Okay, so basically when you find the length of this right here, you're finding the length of that there. Okay, so first thing you want to do is, we know we're going to go from 0 to 2.3 because that's where the region starts, okay? There's not going to be any pi involved here because there is no circular region. And we're not revolving. So the area of an isosceles triangle is 1/2 base squared. Now base is pretty much the length of this right here. Now how do you get the length of that? You pretty much just do top minus bottom. In this case, it's going to be 4 minus the function. And that's it. You plug and chug, you should get your answer. You should get 3.574. Okay, here's the last one. Part C. So here where we have this vertical line. Okay, we don't know necessarily where, but it divides the two regions into two equal areas. So I don't necessarily know where that is, but I do know that that red region and this green region has equal area. Okay, so how do I set this up? If I want them to be equal area, how do I illustrate or how do I show explicitly what the area of that red portion is? So you would have to integrate, okay, top minus bottom. But from where to where? So it starts at 0 and it goes all the way to that k value. Okay. Now that second area, integral, top and bottom hasn't changed. Okay, but it starts at not 0, but actually k, and all the way up to 2.3. So we're going in a forward direction here. Okay, and that's basically it. We don't have to solve it. There you go.